you have a powerful computer inside your skull. Composed of vast networks of neurons and synapses, this computer is capable of performing complex computations. Now, these biological computations can be simulated with mathematical models. Modeling is an incredibly useful tool in representing connectivity in the brain, from individual neurons up to large-scale neural networks. I've been using modeling to explore the mechanisms underlying rumination. Rumination is defined as a pattern of thinking characterized by repetitive, persistent, and often negative self-directed thoughts. Essentially, I'm trying to understand what is happening in the brain when an individual is stuck in this characteristic thought pattern. There is no universally accepted theory as to why some individuals experience strong ruminative tendencies. There are also many different measures of rumination, and this makes it challenging to quantify and to study. I explored the idea that high ruminators may have poor attentional control. Specifically, high ruminators, or people who ruminate a lot, are hypothesized to have an impaired ability to withdraw their attention from distracting information, and this is known as the impaired disengagement hypothesis. To study the link between rumination and attentional control, I assessed performance of low and high ruminators on the Stroop task. In this classic psychology task, participants are presented with color words, which are either incongruent or congruent with their ink color. The baseline Stroop effect shows that all participants consistently take longer to respond on incongruent trials because of attentional competition between the word content and the ink color. Adding in the impaired disengagement hypothesis, high ruminators are expected to take even longer than low ruminators on these incongruent trials because they are unable to effectively withdraw their attention from the distracting word content. Throughout the semester, I collected empirical Stroop data from participants. I also modified a classic model of Stroop task processing by altering how activation propagated through a neural network in high and low ruminative conditions. In matching the Stroop performance from study participants to my model results, I will be able to determine if ruminators become stuck in those repetitive patterns of thought because they are unable to pull their attention onto new information. Now, importantly, rumination is understood to be a factor which contributes to the development and persistence of mood disorders, including depression and OCD. Investigating the mechanistic bases of rumination is therefore a worthwhile pursuit with diverse mental health outcomes. In first answering how ruminative tendencies persevere, we can begin to approach the question of treatment and prevention of associated mood disorders. I look forward to sharing my results. Thank you.